Alright guys, so before we talk about Minecraft in this video, we just have to explain a little bit of history. So guys, this won't take too long, so stick around please. It's gonna last for about 45 seconds. So first of all, I am everything but an expert about World War II, which occurred in the first half of the 20th century. But what I do know about that war, just like in every war, people had to come up with ways to talk to each other, and at the same time they had to make sure that the enemies weren't able to understand what they were saying. So in 1844, Samuel Morse came up with what is now called the Morse code, which consisted of only dashes and dots to represent single letters. But when World War II began, people all around the world were able to communicate using the Morse code. So the Germans invented this machine called the Enigma, which simply put allowed them to write messages and messages that only them were able to understand. Now this machine is of a mind-blowing complexity, so I will not explain how it works in this video. So how about we just go back to Minecraft? So no, this video is not about World War II, but it's about the Enigma machine itself. What I did is I reproduced the Enigma machine and it's working in Minecraft. So here it is. It's mind-blowingly huge. It's also really ugly. It consists of 2,121 command blocks. For those of you who are familiarized with redstone in Minecraft, you guys know what are command blocks. So yes, that's a quick overview of what it looks like. So how about we just go in it and take a look at it in action. Alright guys, we're here in front of my user interface for the Enigma machine I've built, so let's take a look in it. First we have the Enigma temple. Alright, so on your left hand side you're going to see the slash keyboard type of deal for inputting the letters inside the system. And if we just keep going onto this side, you're going to see where the rotors are shown right here. Also, I found this Enigma machine simulator on the internet. It's made by Michael C. Koss, and I'm going to use it to assist me while I'm using the Enigma machine in my Minecraft world. Alright, so right here we've got the starting position at MCK, which I'm going to reproduce on my version in Minecraft. Here you can see that my starting positions are set at 13, 3, and 11, meaning MCK. So I'm going to write A in the input, and in return I'm going to get the letter T. That means that if I go back at my keyboard and I put in A, just like that, I'm going to get the countdown. That starts from 18 and that goes all the way down to 1 before I get my answer, which should technically be a T. Now I'm just going to speed up everything until I get my T, and there you go, I've got T, which is good because that's what I was supposed to get. Along with that, I get the Morse code equivalent of T, which is just a dash, plus if I come and stand right over here and look at the ceiling, I will also get the T value in the Morse code. So now if I go back to where I can see my rotors, you're going to see that the third one changed from 11 to 12, just like the one in the MCKOS version, which changed from K to L. Alright, so before I keep going, you got the point. Every time I press a letter, I get the 18 seconds countdown. So I'm going to deactivate that function just so the screen doesn't get all cluttered with text. So next, I want to change the starting positions for the rotors. So I'm going to go back to the MCKOS website and change MCK for A, H, and D. I'm going to do the same thing to my rotors right here. 13 to 1, 3 to 8, and then we have the last one, 11 to 4. And I just press the button here to confirm the changes and wait for it to happen. Then I want to write Enigma, so let's go to the E and push it. And just so you know, I will skip the countdown so I get the letters faster. Now we start with L and look at the ceiling to see dot dash dot dot, which is the Morse code equivalent for L. Next we have N, which gives us C dash that dash dot. Then we have I, which gives U dot dot dash, and I will not keep showing you guys this Morse code at the ceiling because you get the point, it works. J gives us T, followed by M, which will give us G, and then at last we have A, which will give us L once again. That's it for Enigma, which in total gives us LCU TGL. So let's go back to Michael's Koss simulator and enter Enigma, which also gives us LCU TGL, which, as you can see, proves that everything works. So knowing how Enigma works, we should get Enigma back while putting the LCU TGL in the input section, and there we go, we get Enigma back. Now let's test that function in our simulator in Minecraft. Let's reset the rotors, there we go, back to where they were before. Now let's try an L, which will give us E. Then we have C, which should give us N, and there we go, it works. Let's keep going. So we have U, which gives I. Then we have to put in T, which G. There we go. That's good. All right. Next, there is J, which gives us M, and final letter, which is L, should give us A. There we go. Excellent. Everything works. All right. So now let's go back to the simulator and see that we have AHJ, which should technically give us 1, 8, and 10. So yes, it is. So everything works the same as the Enigma machine would work. Finally, that was it. It's a working version of Enigma, but inside Minecraft. So that was it. Here's another overview of what everything looks like. Again, keep in mind that there is a lot of command blocks. There is 2,121. That's why it takes 18 seconds to process every command that we put in. So again, that's why I skipped the 18 seconds I had to wait between every letters, just to make the video a little bit more interesting. Well, that's it guys. So thanks for watching. I hope you guys enjoyed that. It took me a while to build. I'd like you guys to like the video. That way I can know if you enjoyed it or not. That way I can keep doing videos like this. And do you guys want to see how the machine works and all that? Let me know in the comment section below the video. Besides that, thanks for watching guys. Have a good day.